All right, number 47 is another limit problem. Since I see a cube there, or a cube and a squared, I'm definitely going to go ahead and factor before I do anything else. In my numerator and in my denominator. For this cube, remember our difference of cube pattern is a squared, AB, B squared. And since it's positive in the middle, we would do same, opposite, always positive. Here, our A is going to be a little different. A lot of times we just have like x cubed and then a number in the back. Since we have 0.7x cubed, we're going to have 3x as our A. B is going to be 1. All right, so our numerator is going to look like this. And since I'm doing this all in a line with equal signs in the middle, I'm going to be a good little math student and continue my limit notation until I plug in the negative 1/3. So I'm going to have 3x plus 1. 3x squared. So 3 squared is 9. X squared is x squared. Minus 3x times 1. 3x. Plus 1 squared. I'm going to double check, make sure my signs are right, make sure I squared my 3 and squared my x, and not a squared term. All right, that looks good. Now I'm going to factor the denominator. 6 times negative 1 is negative 6. 2 factors of negative 6 that add to negative 1 are negative 3 and positive 2. If it helps you to see that factor tree, there it is. Remember, to multiply to a negative, you need 1 positive and 1 negative. I'm going to split the middle. I can take a 3x out of the first 2 terms. And I can take a 1 out of the second 2. And my parentheses match. Lovely. And so my factors here, 3x plus 1, 2x minus 1. Even lovelier still is the fact that I can cancel that 3x plus 1, which is what was causing an issue for us taking the limit. So, there's the limit. I'm really taking the limit. I had that removable discontinuity at negative 1/3. So I'm taking the limit of 9x squared minus 3x plus 1 all over 2x minus 1 as I approach negative 1/3. I'm going to drop the limit notation because I'm going to plug in that negative 1/3. This could potentially be on the no calculator portion of your exam, so let's be careful about doing this math here. This is 9 over 1, negative 1/3 squared, square the negative 1, we get positive 1, square the 3, we get 9. Here I have a negative, so it's going to be positive in the middle for this. 3 times 1/3 is 1. So if I want to go ahead and just deal with the top here, my 9's cancel. I have 1 plus 1 plus 1 is 3. And then in the denominator, I have 2 times negative 1/3, so that's going to be negative 2/3 minus 1. I'm going to go ahead and make that into 3/3 so I can handle that subtraction there. Negative 2/3 minus 3/3, I have that common denominator of a 3. Negative 2 minus 3 is negative 5. This is a complex fraction. Something I'm going to go back and fix here really quick is instead of just having a 3 on top, I'm going to write it as 3 over 1. And now you can either flip the second and multiply, and if you're flipping the second, that would be your denominator. Or you can group, and you would group the tops or top and bottom, that would become the top. And the middles here become the denominator, or the bottom of your fraction. So I end up with, I'm doing a positive divided by a negative, so I have a negative. 3 times 3 over 5. So that is negative 9. That's the limit. That's also the y value of your removable discontinuity. So when we were doing that piece, finding the y value of the removable discontinuity of the rational functions unit, you were actually finding the limit as well. Whew, that was a good one. All right, let's see what fun multiple choicey thing we have next. Which of the graphs is negative 2 sine of x plus 4? Okay, you like trig graphing. I'm going to start with sine. Sine is our wave function, and it looks like that. With a negative 2 out front, that does two things. First, that reflects our graph across the x-axis. And it makes our amplitude too. So we can get rid of, if there was an option that didn't have an amplitude of 2, we can get rid of that. So we've dealt with the negative, dealt with the 2. The last thing here is plus pi over 4. So we have a phase shift of pi over 4 to the left. And remember, our normal, period of our function is 2 pi. So half is pi over 2. Another half of that is going to be pi over 4. So since we're not doing any kind of horizontal shrink here, pi over 4 is going to, on both sides here, left and right, is going to kind of be in the middle of that down. So if we move this guy left, pi over 4. Okay, I'm going to do it in, I don't know, bright pink, light pink. If we move this pi over 4 to the left, what's going to happen is we're going to cross the y-axis kind of in the middle of that down slope, in the middle of that down. And so that is happening. Pick this guy up right here, move it pi over 4 to the left, and that is going to be, let's see, not A, not C, that's too far, not B, that doesn't look like it's moved at all. All right, D. All right, we'll fit one more on this video. Which of the following is equal to ln of e over 2? Well, we've got to work with ln of e over 2 first. And the nice thing about ln of e is that it is 1. And that's because the base of ln of e, so e to the first power equals e. So this is actually 1/2. So we're looking at which one of these values down here is equal to 1/2. Well, sine at pi is 0, so that can't be right. Tangent of pi over 4 is 1, so that can't be right. This guy is kind of 5 little problems at once. You have to figure out what ln of e over 2 is, and then you have to figure out what the little guy is reduced to. Cosine of pi over 3, well, that's our big angle in the first quadrant, so we're going over a little and up a lot. Cosine of pi over 3 is 1/2. Sine is radical of 2. 2 times square root of e, well, I wouldn't expect you to do square root of e without a calculator, but remember e is about approximately 2.7. So that would be like 2 times 2 square root of 2.7. So I would say no there. But we know absolutely 100% that cosine of pi over 3 is 1/2. So you can choose B there. I like that one quite a bit. Alright, that'll be it for this video. I think one more video and we'll have the exam with you done.